Another basic thing we need to talk about in this class is with regard to solutions, how concentrated a solution is. It's another quantitative sort of numbers sort of concept. We talked about solutions before when we said that matter can either be, started up here, can either be a pure substance or what's over here. It can be a mixture. And if it's a mixture, what two types of mixtures can it be? It can be a homogeneous or it can be a heterogeneous. Which of these two mixtures is the same throughout? Homogeneous mixture is the same throughout. When we have a solution, that means that you have two or more substances that are physically combined, like mixtures are, and they are the same throughout. So solutions is another type of homogeneous mixture. How's that for kind of pulling things together? So we tend to think of solutions, there's a lot of S's in solutions. So if this is my beaker, a lot of times we're basically dissolving something into a bunch of liquid. This something that we're dissolving is what we call the solute, is there in lesser amount, and the solvent is there in greater amount. I said there's a lot of solutions, so in other words, we can say that a solution, SOL'(N), is equal to what? The solute plus the solvent. Okay, there you go, a lot of S's. Now, if the solvent is water, I'll say water, question mark, which a lot of things are. We dissolve a lot of things in water. Then that makes it an aqueous solution. That's it. Totally it. Solutions. Let's see. I guess we can go down here. Okay. So I mentioned that we generally think of dissolving a solid. Where is it? We dissolve a solid solute into a liquid solvent. Okay, that's kind of what we generally think of. But notice that we could take a gas and dissolve it in liquid. Example of that is carbonated beverages. We could take a liquid and dissolve it into another liquid. Totally works. We could take a gas as a solute and dissolve it in gas as a solvent. That's kind of interesting. I guess maybe an example of that is as you're breathing air right now, what's the most abundant gas that you're breathing? Nitrogen. So as you introduce other gases in the room, guess what? Those would be your solutes dissolving or migrating into solvent. The last one I think is kind of interesting. You could take a solid and admit as a solvent and admit other particles as solute particles. To me, I think I talked about this before when I talked about mixtures, but stainless steel, goodness, I'm butchering that, but stainless steel actually is a homogeneous mixture of metals that are just, how do I say this, they aren't chemically bonded, they're just kind of hanging out together. So that's a possibility right there. So solute is in lesser amount, solvent is in greater amount. I mentioned numbers, and so when we do numbers, when we say how concentrated a solution is, and we're using numbers, usually it is the given amount of solute per a given amount of solution. So solute per solution, usually. That's the units. Sometimes, and we're not going to get to it in Intro to Gen Chem, we actually go amount of solute per a given amount of solvent. I know, lots of S's. But this is amount of solute per given amount of solution. So we're going to actually talk about two ways of talking about how much solute is there in a certain amount of solution. These are just generic terms, no numbers yet here. But if somebody says, I have a concentrated solution, that means there is lots of solute dissolved in that solvent. And if somebody says I have a dilute solution, that means that there is not much solute dissolved in that solvent. Makes sense. It's kind of, the solute is kind of sparse. Okay, so here in the next few slides, the two ways of expressing how concentrated a solution is that I would like to focus on are these. Now remember, whenever you see a per, I'm hoping you think slash or a divisor. So grams of solute, I'll put G solute per liter of solution. So on the bottom I'll put liter of solution. Okay, that's an important way of describing solution concentration. I guess there's a third one I'm going to kind of remind you of in a minute, of saying how concentrated a solution is. So grams of solute per liter of solution. And just to kind of make sure we're all on the same page, remember that solution is both the solvent, which is there in greater amount, plus the solute. Right? Okay, the next one is, let's see, how do we go? Moles of solute per, so on the top I'm going to put moles of solute per, and then it goes on to finish up with liter of solution. Liter of solution. Okay, and again, solution is the solvent plus the little bit of solute, so the volume of solution. Okay, now notice the thing that these both have in common is they have what? The same denominator. Okay, and we're actually going to do a problem coming up. Notice in the numerator I have amount of solute in grams, amount of solute in moles. I'll put it in the form of this question, and I think you've heard this question a few times. Okay, how do we go from grams to moles? Dun dun dun. The molar mass of the compound or the molar mass of whatever you're working with. How do we go from moles to grams? Again, the molar mass. So that's here to stay, isn't it? Oh, down here in purple I say, notice that these both depend upon temperature. They both depend upon temperature. The reason is that volume changes with temperature. So volume, I think we used this delta before, it means changes with temperature. So both grams of solute per liter solution and moles of solute per liter solution depend upon what temperature that your solution is at.